Our team designed and implemented distributed algorithm for factorization of dense symmetric indefinite matrices for ScaleAPAC. ScaleAPAC, as you know, is a scalable parallel library for distributed computers for linear algebra, and it's used by many scientific applications. So we had the following motivation that this type of problems, which are symmetric indefinite, are very common problems, and there was not such a routine or function existed in this library. And we would like to take advantage of the symmetry because the existing implementation of factorization of the LU, factorization with partial pivoting, did not take advantage of that. And the other type of factorization, which you really learn probably in the course, or cannot be used because the matrices do not have property of being positive definite. Also, we have a requirement that the algorithms have to be numerically stable. That means after many iterations, your values do not grow. So we also targeted computers with distributed memory systems, which are very widely used nowadays. So as a model implementation, we used the factorization algorithm, which was already implemented in 0 version in the LAPACK package. And we tried to design our algorithms in such a way that uses standard highly optimized packages for matrix and vector operations, as well as for communication. So on the right side, you can see how the design is organized. So blue corresponds to the computational kernels, and green corresponds to the communication kernels. And you have a dotted line which separates and represents the kernels which are local to each process, and on top you have the kernels which are distributed, so they participate in collective communication. Also, to balance the process load and blocked operations that can take advantage of a local memory hierarchy, we had to use 2D block cyclic distribution of matrix, and which is shown on the right as well, at the bottom. And during our implementation was pretty long and tedious, and we had so it was very time-consuming because to enable block operation, we had to introduce additional workspace when you have to store a part of a matrix in order to use it later. So the logical algorithm of the algorithms was got very complicated. And also because of the requirement of the numerical stability, we had to introduce pivoting to the algorithms. If you don't know what it is, I can explain later at our poster. But it also complicated the communication pattern significantly. So we have the following result, that the algorithm has been implemented, but we have not been able to test and benchmark it thoroughly yet. And also in the future work, we would like to explore such optimization as software pipelining, overlapping computation with communication. So please visit us.
So you'll have a busy weekend then. Good. So.